Hello, this is question 7 on January 2013 core 4 paper from AQA. You have a biologist is investigating the growth of a population of a species of rodent. The biologist proposes this model, which is exponential, for the number of rodents n in the population t weeks after the start of the investigation. So use this model to answer the following questions. We have to find the size of the population at the start of the investigation. As t is the time in weeks after the start of the investigation, at the beginning of the investigation, this t is going to be 0. So we are going to find n when t is 0. So for a, n is going to be 500 divided by 1 plus 9 e to the power of 0. E to the power of 0 is 1, so I have 1 plus 9 is 10, 500 divided by 10 is 50. We don't even need the calculator, and that's the first one. Then second part says find the size of the population 24 weeks after the start of the investigation, and we have to give the answer to the nearest whole number. So now t is 24. So this is 1, 2 is when t is 24. I have n is 500 divided by 1 plus 9 e to the power of minus 24 divided by 8. And we can do this with a calculator very quickly, and it's 345.28, but rounded to nearest whole number. Nearest unit or whole number. So this one, the first one, second. Then the third part says find the number of weeks that it will take the population to reach 400. So now they ask about the time, and they give us the number of rodents, and we have to give the answer in this form. So let's going to see how it looks like. I'm going to do it, well, I don't know, next page, no. 3. So we know that n is 400, so we are going to substitute in the equation n by 400, and we are going to solve the equation, which is an exponential equation, e minus t over 8. We can simplify a bit, and we have, we multiply and we divide by 4, yeah? So we have the 1 plus 9e to the power of minus t, 1 plus 9e to the power of minus t8 is going to be 5 quarters. I subtract 1, so 9e to the power of minus t over 8 is 5 quarters minus 1 is 1 quarter, which means that e to the power of minus t over 8 is 1 quarter divided by 9, which is 1 over 36. And now I can take logs. I'm going to take ln, so ln e to the power of minus t over 8 is going to be ln 1 over 36. ln of e to the power of something is the something, yeah? So minus t over 8. And ln a fraction is ln numerator minus ln denominator, yes, using the properties of the logs. And ln 1 is 0, so I have only minus ln 36, which means that t is going to be 8 ln 36, and that's how it should look, yeah, because they say a whole number, this way. Then b says show that the rate of growth dn by dt is given by this formula. Remember, we are going to just differentiate this expression to find dn by dt, but our answer is going to be in terms of t, and they are just substituting everything back into terms in terms of n. So let's going to see how we can do that. So for bi, I have dn by dt is, we can use the quotient rule, yeah? Derivative of the numerator is 0 times the denominator, so that's cancelled. So remember, when I have, I'm just using this, the derivative is u v minus u v prime divided by v squared, yeah? So this one is 0, so this term is 0. Then minus 500 times the derivative of this one. So minus 500 times the derivative of the denominator, which is, I have an exponent, an exponential, so it's going to be the derivative of this exponential, which is minus 1/8, multiplied at the front. So I have minus 9/8. So minus 9/8, and then the exponential without any changes. And then the denominator is squared. So 1 plus 9e to the power of minus t over 8 squared. And now what I'm going to do is to write that this expression, try to eliminate this e's to the power of something to be able to write in terms of n. And n, I'm going to write here, so we don't forget, is this expression. And I'm sure there are more than one way of doing it. I'm just going to try one. So I can see that this, together with one of the factors in the denominator, is n. So I can write so far that dn by dt is minus, well, I have this minus and this minus, so are gone. I'm not going to write the minus anyway, again. So I have n multiplied by 9/8 e to the power of minus t over 8 in the numerator, and in the denominator I still have one of the factors, the 1 plus 9 e to the power of minus t over 8. And again, using this expression, I can write this denominator, for example, which is this one, as 500 divided by n. Yeah, so from here I can write that 1 plus e to the power of minus t8 is 500 divided by n. So I know this bit here, this denominator, can be written as 500 divided by n. And the same, I can do the 9e to the power of minus t over 8. So this bit here, oh, sorry, I'm missing a 9. Is 1 plus 9. Oh, 1 plus 9. So I can write that 9e to the power of minus t over 8 is 500 divided by n minus 1. So I can write this part of the numerator as 500 divided by n minus 1. So let's see if we can put everything together. Dn by dt is n, and then I have 1/8 brackets 500 over n minus 1. So I've just written this 8, and in this, instead of this, I have written this expression, and then the denominator is 500 divided by n. So all is 500 divided by n. Yeah, and I'm now going to work with the expression a bit. So this n and this n is going to be n squared. This 8 and this 500 becomes 4,000. So I see that things start to become a bit similar. 500, and I'm going to add this fraction, yeah? So, or subtract 500 minus n divided by n. I can cancel this n squared, and I have the expression that I needed, which is the n dt is n over 4,500 minus n. Yeah, that's the expression that we needed to find. Where's that? Here. Yeah. And now we need the maximum rate of growth occurs after t weeks. We have to find the value of t. And it's quite tempting, as we have differentiated, to make that equal to 0. And that's a common mistake. But what they are asking us is the maximum rate of growth. And this is the rate of growth. So we have to maximize this function. We have to differentiate this function with respect to n, which is the parameter. Yeah. So it's not making this equal to 0, because here the growth would be 0. Yeah. So this is the growth. And this is what we need to maximize. So we need to differentiate it with respect to n and make that equal to 0. So to differentiate, I'm going to expand the bracket. Yeah, so I'm going to write this dn as 1 over 4,000, but multiply by 500n minus n squared. Yeah, and when I differentiate the growth, I'm going to call this g because it's less confusing, g from growth. So I'm going to differentiate for the last one. The last one, what's the g with respect to n. I'm going to differentiate that function. So it's the 1 over 4,000 multiplying 500 minus 2n. 500 minus 2n, and this must be equal to 0, which means 500 minus 2n must be 0, which means n must be 250. They ask the weeks, so what we are going to do is to make n equal to 250 in our expression for n. 1 plus, it was plus 9 e to the power of minus t8. We can simplify a bit. So we have 1 plus 9 e to the power minus t8 is going to be 2, which means just subtracting 1, 9 e to the power minus t8 is going to be 1, which means e to the power minus t8 is going to be 1/9. And taking logs, we have ln e to the power minus t8 is going to be ln 1/9. Ln of e to the power of minus t8 is minus t over 8. And the same reason than before, ln 1 minus ln 9. So it's going to be minus ln 9 because ln 1 is 0, which means t is 8 ln 9. And they ask to round to something. Find the value of t. So we can leave it like this. These are exactly the weeks, or we can divide with the calculator and say this is 17.577, so 17.6 weeks, or even 18 weeks, something like that. But I would just leave the exact value. I think it looks just better. Yeah, and that's all with this question.